Okay, x of 0 equals 0. Again, remember, I'll write down what x of t is again. X of t is c1 plus c2 e to the negative gamma over mt plus f applied over gamma, right? Make sure I've got that right. Yeah. Know where all that comes from, but you can easily forget something. So you plug in 0. You quickly, you've only got, okay, left off the C2 because the exponent's 0, the exponential is not 0. See what I mean by being careless? So now you know what C1 and C2 add up to. Let's write out what x prime of t is. It's a C2, well, let's put it in polite grammar. Negative gamma over m C2 plus f applied over gamma equals 0, right? Plus C1. No, C1 goes away because of the derivative. Actually, that goes away too. It's constant. Derivative 0. So C2 equals 0, thus C1 equals negative f applied over gamma.
Isn't that x prime of t 4? Like t is 0. But
yeah, you're right. Yeah. I said it was 4. Look back. So it's 4m over gamma. So that, yeah, let's do it right. I'm glad I had you guys do this first so you see where I'm going wrong. Study and watch me be careless. Okay, so that's 4. So it's C2 equals negative 4m over gamma. Not sure I had the negative sign in there either. Okay? Agree? C1 that's not dimensionally consistent. So there's something wrong in the rest of my, yeah, because units of force and units of mass are different. So these things don't have the same units. They don't have the same dimension. Okay? So that really disturbs me. So I need to look back and see just where all this came from and see if I made a mistake. I'm thinking maybe I left an M out of something. Okay, so let's see. When we do this, we get C equals 0, and that's pretty clear from this. Now we get 2mc plus gamma b equals f applied C 0, so it's f applied over m. That seems to work. The m over gamma thing comes from the gamma over m and that comes in here, that's where it belongs, so we're still going to get m over gamma. So I think there's a mistake in here somewhere. Because the dimensions don't align. But I'm going to go on anyway, because I don't want to stand here and waste class time figuring out the mistake. Something's wrong here. Uh-oh. Okay, so I got to reconcile that to get my solution. Let's go ahead and see what happens if this is a solution. Maybe the absurdity of what we get will cause a light to go on, and I can look back through here. Looking through it, I don't see a problem with it because, again, anyhow, I can't spot it instantly, so this might need fixing, okay? So I want you to go through the solution with a fine-tooth comb for homework. Now, write it all out yourself, independently. Don't try to look at what I did and figure out, is that right or is that wrong? Because when you see it and you know that I did it, you're going to accept it. Your brain's going to be prejudiced to accept it rather than working through it on your own, which is what you need to do, rather than trying to figure out how each step occurred when you're reading a textbook, okay? Do what you can on your own, get to the point where you get stuck, compare that. Don't sit there thinking, okay, this comes from this and this comes from this, okay? Or at least balance the two approaches. How did step 7 come from step 6? I don't understand it. Don't understand it. Go to step 6 and see what happens. Okay? You wasted a lot of time trying to imitate steps that you could actually do. That's just a little side advice. Okay. And, you know, to reconcile this, I'd start over the next day when I'm not in whatever trap I fell into. Okay? Assuming I did, but instincts tell me there's something seriously wrong here. Okay, so anyhow, so now you got C1 and C2. Moving on tentatively. Now we see that x of t should equal C1, which is negative f applied over gamma minus 4m over gamma plus C2, which is plus f applied over gamma. And look at this. This and this add up to 0. Yeah, I really hate that because that just can't be. If you don't have an f applied over gamma in your x function, you ain't going to get one when you solve the equation, okay? So there's something real wrong with this. Now I've got a negative 4m over gamma here and here, and I can factor that out, and that's dimensionally okay. Okay? But does m over gamma have the units of force? And how in the world are derivatives and second derivatives of this going to give you an F applied? Okay? So there's something wrong. But this is the procedure. You take the information you're given, plug it in. Now, gamma is 3, m is 12. So you could plug 3 and 12 in here. Okay? And get a solution. Okay? Now let's solve it in a less messy way. Of course, I pretended to make a mistake. You figure out where it is. And to illustrate why you probably want to do something a little simpler. Okay, well, there's our equation, right? Minus gamma b. Oh, no, that's all right. Okay? That's it. Okay. Can't I write that as mv prime plus gamma v equals F applied? Right? Okay. And having written it this way, can't I write that as m dv dt equals F applied minus gamma v, so that dv dt equals F applied over m minus gamma over m times v. Okay? And you know what? I really don't want to write it that way, because the algebra is just going to be a little trickier. So I'm going to leave it this way. And then I can say, okay, so that rearranges to dv over F applied minus gamma v equals 1 over m dt. Okay? Just dividing both sides by m, kind of multiplying by dt, even though that's not really what you do. Okay? It's just this form is equivalent to this form for reasons that are a little bit subtle. We're not going to worry about right now, but I keep mentioning it. Okay. And then you divide by m if I didn't say that already. Okay? And then you integrate this. So the integral of dv over F applied minus gamma v